Here's the problem that I'm trying to fix today. The bed of my 3D printer is not perfectly flat. When I level the corners, you know, you take a piece of paper and you lower the head and you move the spring so the piece of paper drags on the nozzle. When I level the corners, the center of the bed is actually a little bit too low. And if I perfectly level the center of the bed, the corners touch the nozzle and rub. And here's why that matters. Because until recently, most of what I did was printing right at the center of the bed. So if I leveled with the nozzle around the center of the bed, everything was fine. But recently, I wanted to print this cable chain. And in order to print this cable chain, I need to print a ton of this guy. And when you start printing further out towards the edges of the bed, then the lack of flatness in the bed really matters. These guys at the edge will print fine. These guys in the center will not adhere because the bed is too low. But here's how we're going to fix that. Marlin firmware, that's the firmware that's running on our printer. Marlin firmware has a feature called mesh bed leveling. And mesh bed leveling lets you tell the printer about all the nooks and crannies, all the hills and valleys in your bed. Then the printer will just remember that they're there and move the nozzle up and down to sort of track the contours of the bed and give you perfect first layer adhesion. Well, that's the promise. But mesh bed leveling is not enabled in the firmware on at least my printer by default. So the first thing we're going to do is we're going to download Marlin. We're going to enable those options and we're actually going to compile the firmware. I know it sounds pretty crazy, huh? But I think we can do it. I'm Joshua Bardwell and you're going to learn something today. Hey there, it's Joshua from the future. You can tell because I'm wearing a different shirt and also there's different things on my desk. Here's how I want this video to go. I'm going to show you how to install mesh bed leveling on the Sovol SV01. And it's actually super easy because there's somebody out there who did all the work for us. Then I'm going to show you what mesh bed leveling like what is it? What is it like? Because I really want you to want it. Because then I'm going to show you how to get it working on the Ender 3 Pro, and it's way more involved. And by the time I get to all that nonsense at the end of the video, I really want you to be like, no, this is good. I want this. This is worth the trouble. So if you're a Sovol user, here is just how freaking easy it is. This website is coptertech.de, and this is a wonderful, wonderful person who is pre-compiling builds for the Sovol SV01. So we'll go here to the download section, click on the download link, and we will find the correct file for our printer. Let's see. Well, we want English, so we'll be looking for EN, and we do not have a BL Touch sensor, so we will not be downloading the BL Touch version. We don't have the silent board, so we have the standard board. So we'll be getting Marlin 203 Sovol SV01 en.hex. And now all you got to do is flash that hex file to your printer. It's super easy. You can do it from within your slicer. I'll show you how to do it in the video linked in the video description. In that video, I'm flashing Marlin 2.0 firmware. So it's a different hex file, but the process of flashing it is exactly the same. It's really not that hard. Now, here's where things get radical. Inside the menu, if you go down to bed leveling, you're going to see a new option there. There's the traditional level corners that has always been there, but there's also level bed. And when we do level bed, the printer is going to move to each of the 9 mesh points that we defined. And we are going to use the knob to move the z-axis up and down. Now this is going to be exactly like when you normally level the bed. You're going to take a piece of paper and you're going to slide it under the nozzle, and you're going to use that as a feeler gauge. But instead of adjusting these springs right here, we're going to turn the knob and move the z-axis up or down by minute amounts. And when we've got that point dialed in, we're just going to click the wheel and move to the next point. After you've finished the bed leveling, the next thing to do is to go into the bed leveling menu and set the fade height. And a suggested value for fade height is 20. And then the last thing you must do is store settings. If you do not store settings, then everything you've just done will be lost as soon as you power cycle. Now, although mesh bed leveling can compensate for a lot of variance in the levelness and flatness of your print bed surface, It seems to me like the best place to start is with as level a bed as you can possibly get it. Start from the best foundation and give the software less to compensate for. If you think about it, if your bed is really crazy unlevel, if you're trying to print something that's like tall, the base is not going to be square, right? It's going to kind of angle down. So get the bed as level as you can using traditional ways, and then use the mesh bed leveling to compensate for any little variances that you can't get rid of. Then, when you're done, there's one more thing you need to do. In your slicer, there's something you need to change in your start G code, because the printer will not use the mesh by default when you print unless you tell it to. Let's go do that, and then we'll be done. Now, in order to make sure that that mesh is used for every single print, we're going to make a setting in our slicer. I'm going to click Settings and Manage Printers, and then I'm going to hit Machine Settings. And here, scroll down. No? Okay, we'll just drag it out then. Fine. And here in the Start G code, we're going to find G28 Home. And after G28 Home, we're going to type M420 S1, just like that. M420 S1, and then a little comment here after a semicolon, restore manual mesh. And that will cause the machine to load the mesh every time it prints. But the real power of mesh bed leveling is not just that it compensates for waviness in your bed surface. It's also that it makes it way, way easier to get the exact right nozzle height on your print. Get your first layer just perfect. Let me show you what I mean. I'm going to go ahead and open up a print. It doesn't even really matter what print I open up because we're not going to print the whole thing. I just want to demonstrate this to you. And I am going to multiply this model like 36 times. I'm just going to fill the bed with this little model. Now I'm going to make sure over here on the right that under build plate adhesion, I have skirt selected as my adhesion type. And what that is going to do, and let me set my skirt line count to 4. And if I then slice the file and preview it, you can see that that is going to cause the printer to draw a rectangle basically around the whole outside of the print surface. And that's what I'm going to use to demonstrate how to get your squish just right. So I'm going to go ahead and start this print. And while the printer's heating up, let me show you the real power of this feature. We can go into the Tune menu and we can adjust the bed Z setting. This will allow us to raise the nozzle or lower the nozzle slightly across the entire surface of the bed, even taking into account all the mesh leveling. Well, it's going to be pretty difficult for me to get this on camera, but now that we've got the correct G code loaded, it is much more consistent front to back. I can still see that we've got a little bit of tweaking we could do where the back is just a little more squished than the front, but it is way more even than it was when I was before I did the mesh bed leveling. So I've just let the skirt finish, and I'm going to try and get some close-up shots here to show you guys. Here's the front. It's very hard to keep the focus here. And you can see the front is a little bit high. There's just a little bit of differentiation in the lines there. They're not quite squished together. And in the back left corner, again, it's a little high. You can clearly see the lines there, but as we go around to the back right corner, it's the head nozzle is much lower and the lines are very squished together. Maybe even a little bit too low. Sorry, I'm having a real problem getting that to focus, but at this point, if you are a Sovol user, then you're done here. But you might want to stick around and see just how good you've got it compared to the guys who have the Ender 3 Pro. And I got to be honest with you, this is the very first time that I started to really appreciate how much the Sovol had done for me. The Sovol is more expensive than the Ender, but at least this time it saved me a whole lot of hassle. So if you have the Ender, here are the things you're going to need to overcome. Number one, you're going to need to download and compile the source code for the Marlin 2.0, and you're going to need to tweak it just a little bit to make it right for the Ender as opposed to some other printer. You would think, as popular as the Ender 3 Pro is, that somebody out there would be just pre-compiling just like the Sovol does, but maybe there's just too much like slight variances in the enders. I couldn't find anybody who was distributing precompiled hexes. Problem number 2 that you'll have to overcome is the Ender 3 Pro mainboard doesn't have a bootloader pre-installed. And what that means is that you cannot just plug in USB and flash it the easy way. You're going to need an Avr programming adapter, which I just happen to have because that's the kind of nerd that I am. But you probably don't own one of those already. If you have an Arduino, then you can turn an Arduino into an Avr programming adapter. But I actually just happen to have a dedicated one of those. So the final thing you got to overcome is that the mainboard on the Ender 3 Pro it has so little memory that when you enable mesh bed leveling, the code doesn't fit on the memory, and you got to go in and you got to disable some features before you compile. But I figured out how to make it work, and I'm going to show you all the steps, and hopefully by the end you will have access to this and everything will be fine. But frankly, by the time you buy an Avr adapter and go through all this BS, for about $40 you can get a really good new mainboard with silent stepper motor drivers, and it's just a drop-in replacement. And if you already bought an Ender 3 Pro, and instead of going through all this nonsense, you might want to think about just buying a new mainboard. Drop the mainboard in, plug in USB, flash it, piece of cake, easy peasy. Silent stepper motors, wonderful. Link in the video description to that mainboard if you're thinking of going that direction. Away we go. So the first thing you're going to need to do is download and install the Arduino Runtime environment, and there's a link to that in the video description. Next, we'll go to the Marlin website, and we will download Marlin 2.0. Now here in my Downloads folder, you can see the Marlin 2.0.zip file. And what I'm going to do is just drag that over to my desktop. Next, I'm going to open up that zip file and drag the Marlin 2.0 folder out of the zip file onto my desktop, essentially extracting the zip file to my desktop. Now we're going to customize this for the Ender 3 Pro, so I'm just going to rename that folder from Marlin 2.0.zip to something indicating that this is for the Ender 3 Pro. The next thing you're supposed to do is find some template files that are supposed to already be in this folder, but I couldn't find them. I think they changed the location of where they are in Marlin 2.0. Let me show you where I got them from. Back at the Marlin website, we're going to go to the configuration view /download link, and that will take us to the GitHub repo for Marlin. From here, we're going to click config, and from there, we're going to click examples. And then we're going to scroll down and we're going to find our printer, which is the Ender 3 Pro, which is made by Creality. So we're going to go into Creality and then Ender 3. And these are the 4 files that we need. Now I'm going to right click each of them and open link in new tab, because downloading files from GitHub is kind of a pain in the butt. For each of the files, I'm going to then right click the raw button and save file as, and that will allow me to download each of these 4 files. I'm going to need to do that for each of the 4 files. Finally, I'm going to grab those 4 files that I downloaded and I'm going to copy them into the Marlin folder on my desktop. It will overwrite existing files that are already there, and that's the point. We're updating the generic configuration to be appropriate for the Ender 3 Pro. Back in the Arduino development environment, we're going to hit Tools and Library Manager. We need to download the U8g Lib Lcd Library in order to compile this code. In the Library Manager, we can type U8g Lib and we can search for and download the exact version that's shown here. There will be a couple of hits, but we want to download this exact one. This one. The next thing we need to do is hit File, Preferences. And here in the Additional Boards Manager URLs segment, we are going to paste in this text. You can find this text down in the video description to make it easy for you to find. Next, we'll click Tools and go to Board Arduino Uno or whatever it says and hit Boards Manager. And here in the Boards Manager, we are going to type Sanguino, S-A-N-G-U-I-N-O. You should find the Sanguino board and go ahead and install that. This is the part of the video where some of you go to the comment section and tell me that it would be much easier if I had used Microsoft Visual Studio Code and Platform IO, and maybe that's true, but Arduino is a hassle, at least that I am familiar with and understand. I tried to get Platform IO working, I got stuck, and I went back to the thing I was familiar with. The pain you know is better than the pain you don't. After that finishes downloading, we're going to go to the Tools menu and change our board type to Sanguino. Next, we're going to go and double-click the marlin.ino file in the Marlin folder that you put on your desktop, and that will open the marlin.ino file in the Arduino runtime environment. Now, your screen should look like this. You should see Marlin, but also several other tabs, including configuration.h and configuration.addv.h. That's really important. In the configuration.h tab, we're going to search for the word mesh_bed, and we will find this section about mesh bed leveling. And specifically what we want to find is this line, and we want to delete the 2 slashes at the beginning of the line. Next, we're going to search for LCD_bed_leveling. This will let us use the LCD menu to activate the bed leveling process and work our way through it. Now, at this point, if you were to try to compile the code, you would get an error message because the code is too big to fit in the memory on the Sanguino board. So here is the fix for that. Go into the config_adv.h tab and search for arc_support. When you find that line, #define arc support, comment it out by adding 2 slashes to the beginning. Arc support is a feature that is used by like plasma cutters and laser cutters and water jets, but it is not actually supported by any 3D printing slicer program, so there is no reason for you to have this, and you will never miss it if all you're doing is 3D printing. And disabling this feature clears up enough memory that you can then compile successfully while having mesh bed leveling enabled. After you make this change, make sure you hit File, Save, or Control-S to save the file. Then go to the Tools menu. Double check that your board is set to Sanguino and your processor is set as shown here, ATmega 1284 or ATmega 1284P 16 megahertz. That processor is not the default. You're going to need to make sure you change that. Lastly, hit this check mark to verify. This will compile, and it should finish compiling without any errors, and then you're ready to proceed. Next, we'll open up the Ender to get at the control board because, again, you cannot flash this using USB, at least not until after you finish this process. We're going to install a bootloader as long as we're in there, but for the time being, you're going to have to do all this stuff. I found it easy to do by setting it on its side, and then we're going to come in and we're going to remove these 3 screws on the bottom with a 2mm driver. And there's another screw on the top that you'll need to remove before you can take the cover off. It's a little unexpected that there'd be a screw on top to remove the bottom cover, but that is how they do it. With those 4 screws removed, we can remove this cover. Be careful of the fan lead. Don't pull on that. Just set that somewhere out of the way. I didn't unplug the fan, but you can if you want to. It's up to you. So here is the control board, and here is a closer view of the ISP programming interfaces just to the left of the USB plug where we're going to plug in our AVR programmer. Next, I plugged in the AVR programmer. You're going to do this with the Ender unplugged and turned off. It will get power from the programmer itself, but you don't want it plugged into mains. I had to use a USB extension cord because the ribbon cable that came with my AVR programmer wasn't long enough to reach, but you can see I've made it work. Now on my AVR programmer, the black plastic housing that housed the pins was so big that I couldn't plug it into the ISP header. So I cut that plastic housing off and I very, very carefully clipped the pins onto that thing. This is not a great idea because if you accidentally short circuit 5 volts somewhere it shouldn't be, you could damage things, but I made it work, and so can you one way or another. The next problem we need to solve is that the Windows AVR drivers don't work right, and to fix that we're going to use our old friend Zadig. In Zadig, we're going to click Options, Show All Devices, and then we're going to find the USB ASP. And the driver that we want to change it to is this one. So you're going to change it to libUSB-K and hit Replace Driver, and then it should replace the WinUSB driver on the left with the libUSB-K driver, and then your AVR programmer will work. Next, we'll go back into Arduino and change the programmer from AVR ISP to USB ASP. See at the bottom, it says Programmer USB ASP. And then, finally, we can hit Burn Bootloader and burn the bootloader to the board so forevermore we can use USB to flash it. And I don't think this error message matters. I got this error message, but I was still able to flash and everything seemed to work okay, so I can only assume that the bootloader flashed too, I hope. Finally, we will hit this right arrow, upload using programmer, and the Arduino will flash the firmware to the board, and finally, we will be done. We'll have mesh bed leveling on our Ender 3 Pro. OMG, what a ridiculous freaking slog. Anyway, that is going to do it for today. I hope this has been super helpful. I'm really excited about being able to do bigger prints across my whole bed surface instead of just having to do smaller prints down in the middle. Thank you guys so much for following along. I hope that I made it easy enough to follow along. Kind of pulling together a lot of information here that I wasn't able to find all in one place. So I hope there's been some value for you. Thank you guys so much for watching. If you're interested, I got a playlist of videos about 3D printing and the Sovol SV01 specifically, and links to the Sovol SV01 and all the software and other references that I used in this video down in the video description. Thank you guys so much for watching, and happy printing.